Hello and welcome back to Getting Started with BGFX. In this video we are going to be making a shader and we will finally be seeing something drawn to the screen. But first, what is a shader? Well, a shader program is something that lives on the GPU and it's used to draw stuff to the screen, and it's also used to do some pretty fancy things. Like we can use it to do shadows and blooms and water effects and blur effects, all sorts. There are plenty of shaders, plenty of examples of shaders, such as on Shader Toy, that you can use. They're all free, but for our purposes, we're just going to be using a shader to draw stuff to the screen. Now, a shader program is composed of multiple shaders of different types. For our example, we are just going to be using a vertex shader and a fragment shader, or a pixel shader if you're used to DirectX. So a vertex shader is used to convert our coordinates within the game to clip space. So that is what's used by the GPU to determine what is visible. And the fragment or pixel shader is used to determine the final color of the pixel in our shapes. So you can use it just to set it all to red, or do all sorts of various effects. So what we're going to do is we're just going to take the color straight from the vertex and put it onto the screen. Alright, that's enough talk. Let's dive into it. So first we need to create a special file called variant.def.sc. So this defines the attributes of the vertices that are coming into the shaders, and also the input and output variables within each of the shaders. And what we do is, you can use any old program. I'm using Notepad++. We go vec for v underscore color 0 colon color 0 equals vec for 1.0, 0.0, 0.0, 1.0. Then we need to do the same for our texture coordinates. So we go vec2 v underscore text coord 0 colon text coord 0 equals vec2 0.0, 0.0. So what these two are the variables that get passed from the vertex shader to the fragment or pixel shader. And they'll become clearer once we get into the actual shaders themselves. The next thing we need to do is need to define and map the attributes from our vertex. So we go vec3 a underscore position colon position. Then we go vec4 a underscore color 0 colon color 0. And then finally vec2 a underscore text coord 0 text coord 0. So inside the code we created a vertex layout, and where has it disappeared to? There it is. So the vertex layout defines the layout of each vertex. So we told it that the first 3 floats of our vertex is for the position. The next 4 8-bit integers are for the color, and the last 2 floats are for texture coordinate 0. So you might notice that position, color 0, and text coord 0, text coord 0. So that will map the attributes from our code to variables that we can use inside of our shaders. So first let's save this. I'm going to folder where it is. Repos. Getting started with BGFX. BGFX, so we call this varying.def.sc. It must be this because the shader compiler will be looking for this file. It will give us an error if we don't. Alright, save that. Okay, what we'll do next is we will create the vertex shader. So we'll create a new file. First we need to define our input variables. So we go $input a_position, a_color 0, and then a_text chord 0. And then finally our output variables. So these are the variables that get passed on to our fragment shader. So we define output v_color 0, v_text chord 0. Okay, and we have to name it these, otherwise it will give us an error. I have tried. Now we need to include a special file called BGFX_shader.sh. This file exists inside the BGFX source file, and it has multiple global variables and special macros that we can use. And we'll drop a couple of lines. Now we define the main function for our shader. So BGFX has its own shader language, and it is based on GLSL, which is the shader language for OpenGL. So we go GL_position equals MUL, which is short for multiply, U_model view proj, spell view correctly, proj. Now we need to create a vec4 a_position 1.0. So what this does is that it takes the model view projection matrix, multiplies it with the position that we are providing from our code. So this position is the position inside the game world. It will multiply it with the view projection matrix, which we'll get into in another video, and we'll set the final position, and this position is inside the GPU's clip space. Alright, last thing we need to do is we need to assign the color. So v_color equals a_color 0, and then v_text chord 0 equals a_text chord 0. So this is coming from the vertex that we provide from our code, and then this is the output variable that gets sent on to the fragment or pixel shader. Okay, so now that we've done that, we will save this. We'll call this is the vertex shader, so we'll call it vertex.sc. And finally we need to create our fragment shader. So first we need to define our input variables. This will be the same as the output variables of the vertex shader. Text chord 0. And again we need to include BGFX_shader.sh. Now this is just going to be very simple. This will set the color of our pixel straight from the vertex that we provide. So we go GL_frag color equals v_color 0. So we'll save that. We'll call this frag.sc. And there you go. So this will set the color of our pixel, of whatever pixel this fragment shader is being run on, and it's just going to set the color to the color that we provide in our vertex. Alright, so what we need to do now is we need to build our shaders. Now, because I'm running Windows and I know BGFX is using DirectX, which uses HLSL as its shader language, I'm going to just compile them into HLSL. But if you're using BGFX in the multi-game platform, then you would need to build the shaders for each of the rendering APIs that you want to support and use the one that you need. So what I did in the past is I built all the shaders to all the major languages like DirectX and OpenGL and so on. I packed them all into one big file. When the game was running, I asked BGFX which renderer is it using, and from that I was able to extract out the shader that I needed and use that. Right, so now let's build our shaders. So we need the shader compiler for this. Now this is quite a long command line, so I'm just going to create a batch file for this. So first we're going to compile our fragment shader. So the shader compiler lives in BGFX /build /win64 _vs 2022 /bin /shader c. We're just going to use the release version of this. Doesn't matter which one. Alright, now we need to provide it the file. So we'll go frag.sc. Need to define the output file. We're just going to call it frag.bin. Now we need to give it the type. So we go --type F for fragment. Now we need to give it the platform that we're building on. So this will be Windows. Now we need to tell it the shader language that we want it to build into. So let's go s_5_0 for HLSL version 5. And finally we need to define our include directory. So that is the directory where the BGFX_shader.sh lives. And it is in BGFX/src. Alright, rather than typing the whole lot out again, let's just copy it. So we need to cause vertex.sc and we'll output to vertex.bin. The type is a vertex, so v, and all the rest is the same. Alright, we'll save that. We'll call this build_shaders.bat for batch file. Alright, so let's go into our folder and we'll open up a command line so that we can see any results and any error messages. So we'll run build_shaders.bat. Oops, what happened? Undeclared identifier text chord. So there is an error somewhere. There you go, in the vertex shader text chord. Alright, save that, we'll run it again. Yep. Text chord. I'm sure people were yelling at the screen. Alright, try that again. And there we go. No errors anymore. And we got our two shaders that are in HLSL form. Alright, now it's time to load them in code. To keep things organized, we are going to make a shader class to load and destroy the shader. So first we need to create our header file. So we'll just go add new item. Call this shader.h. Alright, pragma once. Need to include BGFX/BGFX.h. Then we create a class, shader program, public. We'll create the constructor. So this will take in a const char of the vertex shader file name and also the fragment shader file name. Alright, now we're going to create a function to get the program handle so that we can use it in our renderer. And we'll shader program, make it a capital S. Haven't created the variable yet, so of course it's going to complain. Now we need to create our destructor. Alright, now we need to create our variables. First we'll create our program handle. Then we'll create the two handles to hold the individual shaders, so the vertex shader and the fragment shader. And finally we're going to create a little function which will create the individual shader, because the fragment shader and the vertex shader are loaded the same way. They're just different shaders, but they're loaded the same way, so we can just have the single function to create the shader. And it's just going to be a generic file name. Alright, now that we've done that, we'll create the class itself. So we'll create a new file. We'll call this shader.cpp. Alright, first we need to include our shader. Then we need to include fstream so that we can load the files. Then we'll include print so that we can print any error messages. And we also need to include the vector so that they'll hold all the bytes from our shader program, from shader files. Alright, so we'll go shader program, create the constructor. And then we will call this function create shader to create the vertex shader. We'll do the same thing for the fragment shader. And finally we'll create the shader program itself. So shader program equals BGFX create program. We need to give it the vertex shader. We need to give it the fragment shader. And then we want to set this to true. So this will tell BGFX to destroy these individual shaders when we destroy the shader program, which we will do in the destructor, which is what we'll create next. So we'll create the destructor. So we'll call BGFX destroy shader program handle. Alright, so now what we need to do is create the little function that loads the shaders from the file. So it is shader handle. Shader program, create shader, const char file name, it's handle, not handler. Alright, so std ifstream, that means it's an input file, a file name, we're telling it that it's a binary file. Now if not file, then we'll just print an error message. Unable to open file name. Then we'll just return null. Nope, that didn't work. Alright, we'll just leave it at that. Okay, now, first we need to figure out how big this file is. So we need to go file.seekg, and we're starting at the beginning, and we need to go all the way to the end. File.tlg. Then we need to set the what's called the track header to the beginning so that we can read the whole thing. Alright, so now we need to create a vector of chars. This is going to be our file buffer, and it's going to equal file size. So this will hold all the bytes for our file. Now we need to read the whole thing. Give it the pointer to the internal array for the vector, and we'll read the whole lot. So give it the file size, and then we'll go BGFX shader handle shader. So now we've read everything, we can create the shader itself, and we'll do a copy because we don't care about the data once the shader is created. So we can just tell BGFX to copy in the data. File buffer.data, file size. Now we need to check if it's valid or not. So we go if BGFX is valid shader. If it's false, print an error message. So we go print unable to create shader. Finally, we'll close our file and we'll return our created shader. Alright, so that is our shader program in its entirety. So we will build this. No build errors. Now we go back to our main file. So now we create the shader. So at the top we'll need to include our shader header. And we'll create the shader program down here. Shader program. Make it a pointer. Vertex.bin. Frag.bin. Alright, now before we shut down BGFX, we will delete our shader program. So that will destroy the shader program, which in turn destroys the individual shaders. So let's build and run this and see if we get any errors. No errors, fantastic. Alright, now we get to finally see our square. So we can get rid of this touch for now. They'll come back later when we do our renderer. But first we go BGFX set vertex buffer. So give it a view ID and pass in the vertex buffer. Then we set our index buffer. sorry, I just realized this is not the vertex ID. I'm not sure what this variable is. The vertex stream, I'm not sure. I've just always set it to 0. I've never had any problems. And finally, we submit it to the GPU and we provide our shader program. So BGFX, submit. Now we give it a view ID of 0. Shader program. Get program handle. Alright, let's run it. And we'll see our square. No square, give me a moment. And I'm back after a very intensive debug session. So a few things we need to fix. First, in the variant.def.sc I had a text chord 0, so just remove that. Spelling, so rebuild those. Now next thing we'll need to fix is we'll go up to our vertices and just bear with me, change the 1.0s to 0.5s. Okay, and finally when we go down to the set view clear, we also need to clear the depth and the stencil. So we go to a pipe BGFX underscore clear underscore depth and BGFX underscore clear underscore stencil. Alright, and now that we've done that, not a comma, but a pipe. I'm sure you're screaming at me. Now that we've done that, now we can see our square, and trust me, this is a square, but it's showing as a rectangle because we are using something called normalized device coordinates. By default, the x and y axes go from -1 to 1, no matter how big or small the screen is. So the x-axis is -1 here, +1 here. The y-axis is -1 and 1. So our vertices are sitting at 0.5 on all axes. So halfway between the middle of the screen to the left is here. Halfway between the center to the right of the screen is here. Halfway from the center to the top is here. And halfway from the center to the bottom is here. So that's why I was looking at a rectangle. We'll fix this in a later video with a view projection matrix, but for now we have a square, and eagle eyes among you may notice it's white, which I just realized. So I will go, this is to do with the fragment shader, so I'll just fix that up, rebuild the shaders and rerun, and there we go. Now it's using the colors from the vertices. So there is our beautiful square. So that's it for this video. In the next video we will be looking at loading an image from the hard drive and rendering it to the screen. But for now I will push this to GitHub and I'll see you in the next video.